Hello, this is Mr. Collier, and today we're going to solve this trig problem involving two triangles. Okay, so the question says find the height of the flagpole on top of the building. So that would be this distance right here. And let's go ahead and call that x. Okay, now this x is part of this skinny little triangle here, which is not a right triangle. So we have to use the other right triangles in the diagram in order to find x. Okay, so one way to do that is we can find the value or the distance from here, from the top of the flagpole all the way down to the ground. I'll call that y, just to give it a name. And if I look at this distance right here, the height of the building, and call that z. Okay, so then here we can see that x is just going to be equal to y minus z. Right, if we subtract this distance from this distance, we get the height of the flagpole. So that's how we're going to approach this problem. And I'm going to redraw this triangle separately so that we can clearly see it. So this triangle, the green triangle, is the one that contains the side length z, and we've got a 40-degree angle, and this is 20 meters. So we can find this distance z using trigonometry. Let me change the color here. So this is the opposite side to this angle, and this is adjacent. That's hypotenuse. So if we look at SOHCAHTOA, the mnemonic SOHCAHTOA, we have opposite and adjacent, so we want to use tangent in this case to find the length z. So I'm going to do tan 40 degrees equals opposite divided by adjacent, which is z divided by 20. Multiply both sides by 20, and we get z equals 20 tan 40 degrees. Okay? And that would be approximately equal to, let me get my calculator ready. We'll get that approximation in a second. And let's look at how we get the y value here. I'm going to redraw this triangle. Okay, I'm going to redraw this triangle, the red one which contains y. So if I redraw that, I'm going to redraw that over here. Okay, so this side is y. Now this angle is 40 degrees plus 6 degrees is 46 degrees. And the bottom length is 20. Okay, again we have opposite over adjacent, so again I'm going to use tangent. So tan 46 degrees equals, that should be meters there, okay, equals y out of 20. And then to solve, I'm going to multiply both sides by 20. And we get y equals 20 tan 46 degrees. Okay, which is approximately, I think my calculator is ready. We're going to do 20 tan 46, which equals about 20.7. So that's about 20.7 meters. And the other measurement is 20 tan 40 degrees to get my z from the previous part. And that's about 16.8. So that's about 16.8. 16.8 meters. Okay, so recall x equals y minus z. Now I've got two versions of the answers down here. I've got approximately 16.8, and I've also got z equals 20 tan 40. Alright? And for the y value, I've got y is approximately 20.7 meters. I've also got exactly, y is equal to exactly 20 tan 46. So whenever I'm doing some calculations, I want to use the exact number. So I'm going to use those exact numbers to find x. So I'm going to say that x equals, I'm going to take this y value as 20 tan 46, and I'm going to subtract 20 tan 40 degrees. Okay, so if I type that exactly into my calculator, I'm going to get the most exact answer possible. So I'm going to do 20 tan 46 minus 20 tan 40. Okay, that equals about 3.9. So this x value is about 3.9 meters, which is the height of the flagpole.